Hi and welcome to another Holistic 3D tutorial on YouTube. Today I want to talk about texture arrays. Texture arrays is an alternative to using a texture atlas. Now in this video I actually talked about texture atlases and UV values, so if you're not familiar with what they are, I would recommend that you go and have a look. But basically what a UV gives you is kind of some grid reference points on a texture that then map to different vertices on your mesh or 3D object. In this case, you can see we've got a cube. So for every single vertex in a mesh, there's also a UV value. And texture atlases use those UV values to allow just the one image to actually represent many textures that end up in the environment, thus reducing the amount of GPU time needed to process it all. Now, a texture array does exactly the same thing. It's just structured a little differently, which makes it seem a lot more intuitive, although not all platforms actually support their use. And using them in Unity is possible, it's just not really an easy process unless you know what you're doing. Traditionally, UV values, when used with any textures, have always been a vector 2 value, which have a U and a V component, hence the name. And there was always this extra W kind of hanging around, which you either set to 1 or 0 depending on what you might want to process with it. But basically it was a vector 2 value where the U and V values represent X and Y coordinates across the surface of the texture to map little parts of the texture onto a mesh. With texture arrays, we work in three-dimensional textures such that the X and the Y values, or the U and the V values, I should say, don't actually change at all. They stay the same. What changes is the W value. And you can see from this image here that what happens with a texture array is that it's actually made up of a stack of images. Now, the important thing here is that each single image in the texture array has to be the same size, which means that your UV values are fairly constant, or they are constant throughout. And all you need to change is the W value, which is your depth into that texture array. So the image right at the front is going to be an index of 0, then the one behind that will be 1, and then the one behind that will be 2. And so you're only counting up in 1, 2, 3 through that stack of images, which makes a lot more sense than having to fiddle around with the vector 2 values in a texture array to find out what those UVs are. But essentially, which either way you use, you are still working with one image that's getting treated by the GPU. Okay, enough talk. Let's do this in Unity. So I'm in Unity 2020 and I have created a scene with a stock standard Unity cube in it. So this is just the default cube that you'll get if you go right click 3D object and then cube. So bring that in. You'll also need a texture atlas. So although we're using texture arrays, the images in the texture array have to come from somewhere, and they come from a texture atlas. So I've got a Minecraft texture atlas that I've used in my Minecraft course. If you don't have one, you can find one by just Googling. Now I just did a quick Google then, and I Googled Minecraft texture atlas, and like here's one here that you could use. It has to look like this. So it has to be like 16 by 16 tiles that are all exactly the same size, no buffering around the outside. So this one here, not that one. You want the square one that looks like this, and there's an awful lot of them to go through. Like there's another one. This one's not suitable. Just the square ones. This one here, most of them are going to have a great big area like this that's pink, which is transparent usually as far as those tiles go. Okay, so download that image, bring it into Unity. Now select it. You want to turn it into a texture array, and Unity will do this for you automatically, which is nice. So if we go over to the inspector with that texture selected, by default its texture shape is 2D. Click on that box and change it to a 2D array. Then you need to tell it how many columns and rows that you want. Now, I just told you it's 16 by 16 in this case, so you want to put 16 by 16 in there, and then click on apply. Now, as soon as you do that, you're going to get a stack icon show over here in the asset. So just like I showed you before, how those images now all stack up. Can we put this onto here? Not like this, no. The default shaders, the standard shaders and all that, they work with UV values that are vector 2 values. So if you want to do texture arrays at this point in time, you have to write your own shader code or adjust the existing Unity standard shader. I'm going to show you how to write a shader from scratch, and it's quite simple, and I've cut out a lot of the noise in there, but it should give you enough idea of how to sort of extend shaders. That's if you know shader programming. Of course, if you don't, you can take my shader course, which will teach you all you need to know. Okay, so let's go and create a shader, and let's start with our standard surface shader, and we're going to call it texture array. Okay, so let's open this up. All right, so we have all of this in here by default, and we're going to get rid of most of it. So what I'm actually going to suggest you do is delete everything that is inside of those two outer squiggly brackets so that we can put them in by hand rather than editing it. Okay, so the first thing is the properties. So properties basically are the bit that's in the inspector where you pass values through. Okay, so let's give this some squiggly brackets at the top here, and we're going to bring in a main texture, so main tech, and let's call it the albedo because it is basically the color of the thing. And then we give it the format that we can accept, which is 2D array. And we're going to say equals, in this case just white, which is the default one, which is basically white, the color white. And that's enough to bring in values for our shader. And now we can actually create a really simple surface shader with some vertex code in it. So sub shader tags render type equals opaque, and both of those actually need to be in quotes. And then the next line down, we're going to have CG program, because this is where the basis of our program is starting. That's our shader code. Hash pragma surface surf standard full forward shadows, and the vertex part of the shader will be called vert. If you haven't actually developed shaders before, this code will look a little foreign to you, like there's no semicolons on the ends of some of the lines and that, and Visual Studio doesn't seem to like the formatting either, so you've got to do that by hand. Of course, there's no autocomplete either at this point, so Unity declare texture 2D array main tech. Okay, so that gets it ready in the right format. Now we have our struct input float to UV main tech. Float 2 is kind of the equivalent in shader code of a vector 2. The data types are slightly different in shaders because of the way that the GPU needs to use them. Now we're going to have an array index here, which will be our index into the depths of that particular texture array. Okay, so that's all we need inside of that struct for our input. Then we're going to create our void vert in out app data full v out input o, and this is going to be where we are mapping our UV coordinates. Okay, so inside of here we're going to have o.uv underscore main tech equals v dot text coord dot xy, and then our O dot array index equals v dot text coord dot z. Okay, so the depth value there. Now, what is text coord? Text coord is the UV values that are on the mesh. So basically it's saying use the XY values that are on the mesh to get your main part of the texture, and your index will be from the Z coordinate that is on the mesh. Okay, so this is the UVs and this is your W value here. Okay, now next we want to create our surface shader part. Void surf input in out surface output standard O fixed for C for color equals unity sample texture 2D array from our main tech using float 3 for in dot UV main tech and in dot array index, and then O dot albedo, which is our output color basically that you're going to see, equals C the color dot RGB value in there. And then we need an end CG to match our CG program at the top, a bracket to match the sub shader, and finally, if this shader does not work, then you can put a fallback in there, and we will fall back to our diffuse shader. Pretty safe to have a diffuse shader. Okay, so there's the shader code. Again, if you're not familiar with shader code, don't let this scare you away. There's plenty of resources on the Unity website that actually do go through and talk about surface shaders and give lots of code step by step, working up to more complex examples. This is quite a really simple example, but basically what it's doing is what we talked about. It's setting the XY values just to be the values of the main texture, which is just going to be like the whole size of the texture from like 0 to 1, which is what we want now, and the array index of Z, which is your depth that you're going into there. And these values are going to come off the values on the mesh. Okay, so save that. Now we're going to go into Unity and we're going to create a material. So create material, and this material we'll call our texture array. The texture array material, if you select that, come over to the inspector, and where it's got shader, you want to select the one you just made. So it's a custom, and then it will be texture array like that. Now at this point, let's put the block atlas that we've got here, which is our texture array, over onto our material. Okay, so the inspector is going to give you this kind of view here, where you've got like a little blue checkerboard thing going on. Okay, now we can take that material and drag and drop it onto our cube in the scene view. What do we get? Well, we're getting the stone texture on the cube, which means it's kind of working, right? But how do we actually change this? Okay, we've ended up like on index 0 or 1, depending on what that W value is for the UVs on each of these vertices. But we can't change it from here. Now, we could actually hard code it into the shader. So if we go back into the shader, and where we are putting in this Z here, if we went like, I don't know, just pick a number, 5, and let's just put a semicolon and comment this out, save it. Let's go back into Unity, and now you can see that it's updated to stone bricks or something. I think that one is, okay? But it still doesn't help you if you want to use a texture array across a whole bunch of different cubes with different values, does it? Because you can't set it to anything else unless you change it inside of here, which is a real pain to do for a particular material. So let's just change that back to the texture coordinate Z and come back into Unity. You actually need to go into the cube's data for the vertices and manipulate with script the actual UV values. So let me show you how to do that. Right click, let's create a C# script, and we'll call it set UVs, and we want to open that up. Okay, so this is actually quite simple, this code. What I'm going to do is set this to execute in edit mode so that we can see it running without having to press play. Then what I'm going to do is actually get rid of the start and the update. We're not going to use those. First of all, we're going to create a slider that we can set for our index. So we want range 0, 256, and then we want a public int index equals 0, like that. Okay, so that'll allow us to change it. Now, we want a void on validate. Now, on validate will run whenever you change that slider. Okay, so it helps us to update our UV values in here. If you wanted to use this code in a runtime version of something and set the UV values or the index from there, then you would make this a start or an awake. You don't necessarily want it inside of an update unless you're changing things, because you don't want this running over and over again, because there's no need to once you've set it. So first of all, we'll create a list of vector 3s called UVs, and we're going to make that a new list of vector 3s, and then we're going to get the mesh that's on this object. So it's mesh, and let's just call it mesh equals this dot get component mesh filter dot mesh, and then mesh dot get UVs 0 UVS. Okay, so we're putting the UVs in there. So get UVs, get all of the UVs that are already on the mesh. Saves us writing them all out from scratch, because that would just be a lot of code. Now we're getting the UVs from channel 0, which is the main texture that you have on something, and putting them into our UVs list. We're then going to loop through this. So for int I equals 0, I is less than UVs dot count I plus plus UVs I equals new vector 3, where the UVs I dot x and UVs I dot y, which are your u and v values, are staying what they already were, but the w or the z value in this case is going to become whatever you've set index to there. Now once you've done that, we can go mesh dot set UVs back onto that mesh on channel 0 UVS. Okay, great, done. So save that. Let's go back into Unity, and we're going to grab hold of our set UVs script and actually put it on that cube. Then select the cube, and over in the inspector you've got an index value that you can now change, and look how it goes up through that texture array stack. And if we duplicate the cube, bring that over here, now you'll know that one issue with creating material is if you change the material, then you basically change it for everyone that's using that material. But with this script, you're changing the actual UV value. So you're using the same material, but you're looking at a different point in that material in the Z direction or the W direction. So you can actually change it using the slider. Okay, so that's it. That's what texture arrays are all about, and that's how to start manipulating them if you want to use those rather than a texture atlas. So I hope you enjoyed this tutorial. Please subscribe. Don't forget to check out my courses that I've got on H3D Learn, especially my updated and brand new Minecraft course. It's been 4 years in the waiting for me to update it, and it's updated now with the new Unity Mesh API and also parallel processing and all sorts of things. It just makes it so much faster than it originally was. Okay, well, I look forward to talking to you next time.